Hiya! Hiya! No. How are you doing, guys? Another problem. Moment distribution. What is the first step that we have to do? Well, what is new here? What is new here is that we have these far end hinges or pin supports, and I'm going to solve this problem actually in three different ways. The longest way, which is going to be this one, and then we're gonna solve it in a medium way, taking advantage of some properties and some things that we can simplify, and then the last way, the fastest way, I'm gonna leave it for the end. So this is gonna be the longest way. No matter what, it's gonna be also a short problem. The first thing that we have to do is calculate K for every member, and remember K, the relative stiffness K, if E is constant, it's gonna be I divided by L for every member. And I'm just gonna put it here. So for this member, it's gonna be K is gonna be I divided by 15. This one is gonna be I divided by 20, and this one is gonna be I divided by 15. The second thing that we have to do is calculating the distribution factors. And the distribution factors are the let's talk about AB. So the distribution factor AB, because it's a fixed support, is gonna be 1. Why is 1? Well, because it's going to be the distribution factor of the member AB, which is 1 divided by 15, divided by the distribution factor of the summation of the not the distribution factor, I'm sorry, the K of the member AB divided by the summation of the K's. So distribution factor, remember, is the K of the member divided by the summation of the K's, either relative or absolute, but it's the same. Now in this case, it's going to be I divided by 15 divided by I divided by 15 plus, this is this, plus whatever is here. There's nothing there, so this is going to be 1. The distribution factor for for BA is going to be I divided by 15 divided by this plus this. I divided by 15 plus I divided by 20. And this is 0.57. Now I don't have to calculate BC, because if you look at the joint B, I know the distribution factor BC is going to be 0.43, because 0.57 minus 1, that's the difference. However, I'm just going to demonstrate that. So this is going to be I divided by 20, I divided by 20 divided by this plus that. And this is what I already said before, 0.43. Now you have distribution factor CB. Well, distribution factor CB is I-20. I-20 sounds like a visa for students. I-20 divided by I-20 plus I-15, so it's going to be the same value as this one. And the distribution factor for CD is going to be I-15 divided by I-20 plus I-15, which is this one. And the distribution factor for DC is 1, which is the same one as this one. Now our distribution factors are done and completed. What is the third step? The third step. Find the fixed end moments. And this is where I'm going to have a little difference, or we're going to have a little difference with the previous cases. Because now what we have is this situation. We have a situation. Where is my situation? Triangular load, triangular load. This is the triangular load. Triangular load. I know, and I'm gonna just mention it, that thing here. I know that I should be using this, because this is far end pin. However, I'm gonna use these. I'm gonna use this, and I'm going to solve the problem as I'm locking also that member, and then unlocking it, lock and lock, lock and lock. That's why I say it's the longest method, because I'm gonna do it as if I don't know that I could use this one. Remember, keep that in mind while I'm doing it. The second version, we will be using this one. So for this one, the fixed moment AB is going to be W L squared divided by 30 from that table, and this is W is 4 times 225, 425, 4 times 225 divided by 30, and that's 30. And remember, the units is keep foot, and the fixed moment for BA will be negative WL squared divided by 12. Let me see again. WL squared divided by 20. Yeah, WL squared divided by 20. Because basically what we're doing is, I'm assuming, once again, I know, don't kill me with the comments and with the questions. I'm using this approach, like the only thing that I know is fixed, and I don't have the other tables, the other possibilities, or I didn't deduct, I didn't do the derivations for that thing. So what I'm having for this particular type of situation, if I use this is gonna be WL squared divided by 30, and this is gonna be WL squared divided by 20. That's what I'm doing. A, B. I'm using this approach, this thing. For that would be for that one. The fixed moment now, fixed moment for BC. The fixed moment for BC is WL squared divided by 12, and we have done that before, 133.3. And the fixed moment for CB is also this, but negative 133.3. We did that before, remember, for this one. It was this, and that. And then you have that, and you have that. WL squared divided by 12. And this is negative according to our convention, WL squared divided by 12. And for the last one, which is this one, the fixed moment for CD. Now the fixed moment for CD, this triangle, is opposite to this triangle. So it's going to be WL squared divided by 20. That's what it's going to be. By the way, I never put the value here for this one. That was negative 45. So this is 45. And the fixed moment for DC will be WL squared divided, negative WL squared divided by 30, which is negative 30. So now we have, and keep fit all the time, remember, keep fit. Now, this is all that we have. What am I missing? Am I missing anything? The carry-on factor. Well, the carry-on factor is 0.5, like usually it is. And now once we have that, we can start working with our moments. And this problem, the only thing that I'm going to do is calculate the moments at the end. That's the only thing that we are doing. I'm not going to go and do the enforced members or anything like that. Distribution factors. This is 1, BA 0.57, 0.43, CB, where are you? CB, why did I put here? Yeah, CB here, 0.43, CD 0.57, and this one is 1. And fixed end moments for AB 30, negative 45, 133.3, negative 133.3, 45, and negative 30. And we're ready to start. Same like before. The procedure is the same. It's just an iteration process. Look for the most unbalanced joint here. Well, actually, we don't have the most unbalanced joint. We have the most unbalanced joints, two of them. And you can see that joint B and joint C are equally unbalanced. So that gives me a possibility to do this. 133.33333. Let me put it here. 133.3333333 plus 45. No, plus 45. Animal. Negative 45. 88.3 periodic. 88.3 periodic. So then what do I have to do? Now this value has to be distributed according to these coefficients here. So I'm going to multiply that by 57, and that will give me negative 50.3 periodic. I know, I'm just tired of putting the periodic thing here, but periodic. And the rest from the 88.3, what I have to distribute, it has to be here. So this is going to be 38, negative 38. That's it. But now I'm gonna balance this the same way. So in this case, I'm gonna need the same 88.3, but this time it's gonna be positive. So in this end, when I multiply that 88.33 times this, is gonna give me positive 38, and this is gonna give me here positive 50.3. That's what is gonna happen there. Now this is balanced, but now this is going to transfer to this end, this is going to transfer to this end, this is going to transfer here, and this is going to transfer there. That's what is going to happen. So now this is going to transfer here, negative 19. This is going to transfer here, positive 19. This is going to be transferring to this side, negative 25.15 here, and 25.15. That's it. The carryover factor for the fixed support is 0. So we're gonna stop there. Now I have this thing here. Now I need to compensate for this 19 and for this negative 19. What do we do with this 19? I'm gonna multiply negative 19 times that, and that's going to give me negative 10.8 or negative 10.83, and the difference here is going to be negative 8.2, and to compensate for this is going to be here 8.2 because it's negative 19 times that, and I need a positive, and 10.8 here. Now this is log, this is log. Guess what? Transmit, 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 and transmit. Every single end is going to be transmitted. Transmit this to this part, negative 5.4. Transmit this here, negative 4.1, positive 4.1, 5.4. What is the next balancing that we have to do? We have to compensate for 4.1. 4.1 times 0.57. That's going to be 2.3 negative, because this is positive. Negative 2.3, meaning this value here is going to be negative 1.8. I'm sorry. Now compensate for this, 1.8, 2.3. Transmit 1.15, transmit negative 1.15. This is log, right? I say. Now transmit down and transmit down. 0.9, negative 0.9. Compensate for 0.9. How? 0.9 times 0.57. That's 0.51 or 0.51. 0.51. Negative, because this is positive, negative 0.38. 0.30, I'm sorry, 39, 0.39 and 0.51. Locked, locked, transmit 0.25, transmit negative 0.25, transmit 0.2, negative, positive 0.2, compensate 0.2 times 0.57, is well, this is not actually 0.2, but this is what I'm putting, right? It's 0.39 divided by 2 is 0.195. 0.195 times 0.57 is gonna give me like 0.1 here. 0.1. I don't know. .1. Yeah, I can transfer that. Or now I can come and I try to look in the balancing of all of these things that I haven't touched from the beginning. I had to touch this. Let me see how this is behaving right now. These joints. Negative 30 plus 25.15 plus 5.4 plus 1.15 plus 0.25. This is 1.95 so far, and it needs to be 0. I know this needs to be 0. So then that means that I need to compensate this. This error is sufficiently low, so I think that I can stay here like that maybe. So I'm going to compensate this with negative 1.95, and I'm going to send half of that in this way, because I'm using the first approach, that assuming that everything is possible to transmit everything. 0.975, and this is gonna be unstable by 1.95, not unstable, unbalanced. 0.975 transmitted in this way. Now if I add these two, now this is 0, which I love because it has to be 0. Has to be 0. Now when I check this joint here, this joint is 0.975 plus 0.2. That's 1.175 times negative 0.57. It's not negative 0.67. I'm just changing the sign of this. So this is negative 0.67, and this is equal to negative 0.505, 0.505, 0.67. Now I can keep going, but I'm gonna stop here because this error I don't think is gonna be that much. So let's add this and let's add that, and that allows us also to calculate the value. So this is 0, this is 0, those two are balanced, and I'm balancing these two also. If I add these, negative 108.6, 108.6, negative 108.6, 108.600, and that will be the n-force members for this this beam. Now keep in mind, I stopped it here. I can keep going, it doesn't matter. I can get this now, and I say, oh, this is gonna transmit 0.32 here, which is gonna be 0.32 divided here, send here, send here, send here, send here, send back. But maybe I'm gonna change the second decimal. Maybe I'm gonna change the first decimal. But definitely the units are not gonna be changed. So this is the longest method. Keep this in mind for solving that. However, even though it's the longest method, let me just put here longest method. Even though it's the longest method, it's short compared with everything else that we have done. Now let me go and work the part number 2. The part number 2, what I'm going to do is I'm going to take this as this equation, like that, and I'm gonna contemplate the carryover factor for hinges 0, which I know in some part of this video I mentioned 0, but I was going one step forward. in this video I consider the carry-off factor 0.5 for all of them. But in the part 2, I'm gonna consider it 0 because we did that derivation when we did the assumptions and conventions for in the introductory lecture of moment distribution. Watch the next video, guys. Stay safe. Bye.